Hello everyone, let's think of a triangle with side length 13, 14 and 15. What will be the height of the triangle H? To find out, let's assume that the height divides the base into x and 14 minus x. Because the left and the right triangles are both the right triangles, we can use Pythagorean theorem. For the left triangle, x squared plus h squared is 13 squared. For the right triangle, 14 minus x squared plus h squared is 15 squared. When we subtract these two equations, x squared and h squared are eliminated, and the value of x is 5. As 5 squared plus 12 squared is equal to 13 squared, the height or altitude of the triangle is 12. One interesting thing about this triangle is that the altitude and the side length are made of consecutive integers 12, 13, 14, and 15. Will there be any other triangle with the altitude and side length made of consecutive integers? If the altitude is the smallest integer x, the base could be x plus 1 or x plus 3. We've already found out the case in which the base is x plus 2. In such case, x is 12 and the base is 14. For the first case, if the base is x plus 1, the altitude x will divide the base into y and x plus 1 minus y. When we use Pythagorean theorem, x squared plus y squared is x plus 2 squared, and x squared plus x plus 1 minus y squared is x plus 3 squared. When we subtract these two equations, y becomes x squared minus 4 divided by 2 times x plus 1. From the first equation, y squared is 4x plus 4. If we substitute x squared minus 4 over 2 times x plus 1 for y, x squared minus 4 over 2 times x plus 1 squared is equal to 4x plus 4. When we open the squares and simplify the expression, cubic equation comes out. Because no factor of 48 satisfies the equation, there is no integer solution. The actual value of x is close to 19.07. If the base is x plus 3, the altitude x will divide the base into y and x plus 3 minus y. When we use Pythagorean theorem, x squared plus y squared is x plus 1 squared, and x squared plus x plus 3 minus y squared is x plus 2 squared. When you subtract these two equations, y is x squared plus 4x plus 6 divided by 2 times x plus 3. From the first equation, y squared is 2x plus 1. If we substitute x squared plus 4x plus 6 over 2 times x plus 3 for y, x squared plus 4x plus 6 divided by 2 times x plus 3 squared is 2x plus 1. When we open the squares and simplify the expression, a cubic equation comes out. Because no factor of 48 satisfies the equation, there is no integer solution. The actual value of x is about 5.7. If the altitude is x plus 1, the base should be x because the other sides should be greater than x plus 1. If the base is x, the altitude x plus 1 will divide the base into y and x minus y. When we use Pythagorean theorem, x plus 1 squared plus y squared is x plus 2 squared, and x plus 1 squared plus x minus y squared is x plus 3 squared. When you subtract these two equations, y becomes x squared minus 2x minus 5 divided by 2x. From the first equation, y squared is 2x plus 3. If we substitute x squared minus 2x minus 5 over 2x for y, x squared minus 2x minus 5 over 2x squared is equal to 2x plus 3. When we open the squares and simplify the expression, a quartic equation comes out. Because no factor of 25 satisfies the equation, there is no integer solution. The actual value of x is about 1.26 or 13.24. Therefore, this is the only triangle with the altitude and side length made of consecutive integers, although there could be an infinite number of triangles.